Hi, my name's Stewart Lynch, and in this video we're going to explore type extensions for Swift and SwiftUI. We'll look at the three different types of extensions for types that allow you to extend the capabilities of a type by adding new methods, properties, or subscripts. Thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. If this is something you want to learn, then keep watching. I have a starter set of playground pages that I created for this video, and I encourage you to download it from the link in the description and work along with me. Once completed, you'll have something that you'll be able to refer back to in the future. If you're not seeing this rendered markup, make sure that you set that option from the editor menu as described here. It'll make navigation between pages much easier. So let's get started. In Swift, a type refers to a specific kind of value or object that can be used in a program. For every value and variable in Swift, it has a type, which determines the kind of data it can store and what operations can be performed on it. Types in Swift can be divided into two categories: value types and reference types. And value types include the basic types like an int, a float, double, bool, string, and also include more complex types like structs and enums. So we're going to explore the way that we can extend these types through extensions. On the first page of this playground, I provided a sentence variable and a word. Both are strings. What I want to do is to create two extensions. One that will count the number of words in a multi-line string like this sentence, and the second that will scramble the letters in a string like word. Before we create an extension, let's see how we can do this in our code without using an extension. Strings have a function called components that returns an array containing substrings from that string that have been divided by characters in a given set. So if we say var words equals sentence, and then apply the components method to this, we're asked to supply a character set to check on to determine the separation. So let's open the Apple documentation page and search for character set. You'll see that there are lots of them. And one advantage of checking out documentation is that you often discover things that you may not have been aware of before. Now, as I look through this list, I see that white spaces might be a good candidate, so let's try that. And then we can print out the array of words to the console. I see that we have a problem in that the new line character is not a white space, so party and we are considered a single word. So if we return to the documentation then, let's take a look at an alternative to include white spaces and new lines. It seems to make sense to me. So let's test it instead. And let's also print out the actual count of the number of elements in this word array. Well, this is better. I see that we have 23 words in the array. But let's add an extra line break between the first and second sentences. And let's run again. This time it indicates that we have 24 words. And I see that one of our words is an empty string, so this isn't good. So what we need to do is filter that out. And we can do that on the words array using the array's filter method. And we'll do it right here, where we'll check each iterated value using $0 that is not equal to an empty string, and therefore filter that out. Now we see that we have just words in the array, and our count is back to 23, which is correct. Well, if you're going to be doing this a lot, you could create a computed property for this that will return an integer. But if you want to do this a lot, we'll create a computed property for all strings that we can use anywhere. And this is what we can do in an extension. So normally I'd create these in a file of their own, but right now let's just create it at the top of this file, and we'll create an extension on string. I'm going to call this computed property word count, and it'll be of type int. Now, since this is an extension on all strings, we have access to the actual string using the keyword self. And then we can call the components method on it to separate it by white spaces and new lines. And we'll use the same filter to filter out those empty strings. And then apply the count so that we're returning an int value. So in example 2, we simply call this computed property on the string sentence and print it out. And I see that we get the correct number 23. In this next example, I want to take any string like word and scramble the letters. Well, I know that a sequence has a shuffled method that'll do that for us. It turns out that I can use this on Word to print them out. Well, it looks like we're getting an array of strings that are letters actually shuffled, but that's not what I want. In fact, if I option click on the letters, I see that it's actually an array of string elements, not string. So what I can simply do is to convert this to a string simply by surrounding the variable with the string and print it out. Here's our scrambled word. So let's create another extension to string for this process. I'm going to add a new computed property to my existing extension, and I'm going to call it scrambled. And this time it's going to be of type string. Well, in the body, I can use the self, which is the word .shuffled, and then convert it to a string. And that's what's going to get returned. So now in my fourth example, I can simply print word.scrambled. I don't have to worry about that syntax. And this will work on any string. So for example, if I create a string Stewart and apply the scrambled computed property to it and print it out, I see that it works. And notice that since I'm using a computed property, there are no parentheses used as we use for the sequences shuffled method. On that first page, our extensions were computed properties on that type of string. Well, this time we're going to look at an extension on a type as a function. So consider this double number. Now, Swift has a method for double that is rounded. So as you can see here in example 1, if I print number.rounded, which itself is a function, it simply rounds to 0 decimal places. Well, what if we want to round this number to 3 decimal places? In order to do this, all we have to do is multiply any number by 1,000 and then round it, and then divide by 1,000 again. So let's set up a variable for this. We'll call it number rounded to 3 decimal places, and that's going to be equal to 1,000 times the number, and then we'll use the rounded method on it, and then divide by 1,000. And we can print that out. Perfect. Well, this looks like a good example for an extension on doubles if I want to have a whole bunch of numbers that are rounded to 3 decimal places. So let's do that first as a computed property on double. So we'll create an extension for double, and I'm going to create a computed property called 3places, which itself will be a double. Well, like our string extension, we have access to the double as self, so we'll simply return the same as our example, but the number variable becomes self. Then in example 3, we can apply this to our number and print it out. So we're going to print number.3desc. Well, as you can see, 1,000 is 10 to the power of 3, which corresponds to our number of decimal places. So we can use a Swift function called POW, or POW, standing for power, that allows us to provide a base, which is 10 in our case, and the exponent is 3, so 10 to the third is 1,000. So our body then can be rewritten as POW 10, 3 times self, that whole thing rounded, and then we divide by that same power of 10 to the third. And we see we get the same result. Now, if we want to be able to round to any specific number of places, then we can simply change 3 to that required number. Well, there are no arguments for a computed property, but there are for functions. So instead of a computed property, I'm going to create a function in our extension that has a parameter that we can pass in, and that parameter is going to be an int representing the power, and it will then return another double. Within the body of the function, then, we can paste in the body of our computed property and just change power 3 to our places parameters label. This causes an issue, however, because it says that we can't convert the value of type int to the expected type argument double. And you see that places is underlined in that red error marker. That's because we pass in places as an int specifically, so we can't, as what happens in our computed property, assume that it's a double. So we must surround places with double and do a conversion. So let's let Xcode do that for us, and we'll do that in both cases. With this function now, then we can choose whatever place we want to round to and print it out. So as the question asks, let's start with a round to 2 places, and then we'll copy and paste that 2 more times and change the place to 3 and 4. Running this, perfect. In the last example of this section, I want to create an extension on an array that when used will not crash my app if I ask for a value at an index that doesn't exist. For example, here is my array called myArray, which has 3 elements, 1, 2, and 3, all ints. In example 1, let me print out the value for my array at index 1. And I see that there's no issue. It picks 2, the item at index 1. Remember, arrays are 0-based, so 1 is at index 0. In the second example, let me print out the value of the array at index 3. And when I try this, my app crashes because there is no item at index 3. The highest index is 2. So let me comment this out so that we don't get a crash in the future. To solve this dilemma, Swift has something called an optional. And if something is an optional and it doesn't exist, then it returns nil. So what I can do is create an extension to an array that doesn't return an element of the type, but rather an optional version of the element, so that if it doesn't exist, it won't crash the app, it'll simply return nil. Now we know we have multiple ways in Swift to check optionals like guard or if-let, or simply checking to see if something is nil. So let's create an extension on array. Well, this time it's not a computed property nor a function. We're writing the extension on the subscript. So we can start with the array's built-in subscript method. This subscript is an int representing the index, and when we request it, we don't provide a label for the index. If we want to distinguish our version from the default, we'll need to apply a label, and instead of returning the element, which can be any type of object that the array contains, we'll return an optional element. Well, for the body then, we'll check to see if the index is less than count. And if so, then we'll return the given index for the array itself. Else, we'll return nil. Well, we can shorten this using a ternary operator, the WTF operator. W stands for what? Well, that's what we have to be checking on, which is if index is less than count. The T is true, which is the true case, which is self at index, and F is the false case, which is nil. So I can test this extension now. First, let me check for my array's safe version at index 1. As you see, we get an optional value this time, so we'd have to unwrap it using a guard check or an if-let in our code. In the next example then, let's try our safe index version at index 3. This time there's no crash, and we get nil. For this final example, I've created a very simple starter project that uses SwiftUI. SwiftUI allows us to create quick interfaces by constructing a number of different views. Perhaps there might be some advantage now then to creating extensions of a Swift view type. Well, there are two things here that we can do to improve this project. You can see that it's a simple VStack that contains two text fields. The first one uses the default keyboard type as none has been specified, but the second one is using a number pad type keyboard. Below that are two text views with similar styling. Well, let me show you the first issue I have by running this in the simulator and making sure that when I tap in one of my text fields, my keyboard's displayed. So when I tap on the name field, the keyboard's presented, and I'm going to type in my name or some name and simply press return, and the keyboard gets dismissed. When I tap the age field, however, I can enter numbers, but there's no way currently to dismiss the keyboard unless I go back to the name one and then press return once again. Well, focus state was introduced in iOS 15, and that would solve this problem for us, but it's an added layer of complexity to my view struct that might not be necessary if we can invoke the UI application's resign first responder method whenever we tap outside of a text field, which in our case would be anywhere on that navigation stack. So let's do that by creating an extension on view. I'll normally again put this in a separate file, but for convenience sake here, let's just write it outside of my content view struct. I'm going to create a function called hideKeyboard that will return some view. That's the way SwiftUI works. Views are simply replaced by different views. What I want to do is attach an on-tap gesture to this view, which is self. And then within the body, I can call the UI application's shared.sendAction method. And from here we can call the method, which is a selector, so #selector, and we'll call the UI responder's resign first responder method. And then we can pass in nil for all of the other three arguments. Now I can go back to my view and apply this function on our navigation stack, which is just a view. So, hideKeyboard. So let me run one more time in my simulator. And now when I enter any field, I can tap anywhere outside and the keyboard gets dismissed. And that includes our number field. The second thing I want to solve is this duplication of code. These modifiers all modify and return a new view in its place, just as our hideKeyboard function did. They are almost the same, except that I use a different font and color in each of the two views. And that frame modifier here just lets me align the text to the leading edge of the screen without having to embed it in an H stack with a spacer. So you may say that this should be a view modifier, and we'll get to that. But it doesn't have to be. It can simply be an extension to a view. So I'm going to create a new extension to view. And inside there, I'm going to create a function that I'll call custom style that has two properties. One for font and one for color. And it'll return some view. Then I can use the view, which is self. And then I can just copy and paste the view modifiers from any one of my text fields, and then just simply change the font and color to the two parameter labels. Then we can go back and comment out those modifiers to our text fields and apply this new custom style, and each time passing in a specific font and color of our choice. And as you see, this has the same effect. So let's go back now and take a look at this as if I'd created it as a view modifier. So let's create a view modifier in Swift. And I have a video on this topic where I go into much more detail, and I'll leave a link in the description. So that view modifier is a struct. I'm going to call it custom style, and it will be of type view modifier. And the view modifier has a single requirement, which is a function called body that accepts the calling content and returns some new view based on modifications to that content. So I want to pass in a font and a color like my function, but these need to be properties of a struct. One for font and one for color. Well, content then is exactly the same as view in our extension. So we can apply exactly the same modifiers to this content as we did to self because we're using the same argument property names. So let's comment out our custom style view extension function now and replace that with a modifier method for a view. And that modifier method requires that we pass in a view modifier, which is custom style. And it requires a font and a color, and we use a different one for each of our two cases. Again, we get the same result. This, however, is not very Swifty. The syntax is pretty ugly. And I actually prefer my view extensions, which essentially does the same thing. And I posted this on Twitter and Mastodon, and the general consensus was that we really should be using a view modifier. But we can improve on this by creating another view extension that will be fairly similar to our function in its design. So I'll create a new extension. And to avoid naming conflict, I'm going to call my function custom style 2, but it's going to have exactly the same arguments and return some view just as our function did. Then for the body then, since it's an extension on view, we have access to self. And for self, we can apply a modifier method. And that modifier requires a view modifier, which is custom style. And then we can just match up our font and color. And it gets returned. So returning once more to our text view, we can comment out this verbose method and use custom style 2, passing in different fonts and bodies each time. It looks pretty similar to my custom style view extension though, doesn't it? Well, I hope that this has provided you with some insights on how you will be able to start creating and utilizing your own extensions in the future. There are many view extensions that people have created and shared, so I recommend that you Google that topic. You'll find many for color and formatting and other things. And as the Swift language itself evolves, we're finding that many of those custom extensions are being replaced by built-in properties and methods in Swift itself. Well, I hope you've enjoyed this video. And if you have, please give it a thumbs up and leave me a comment. Be sure to subscribe to my channel and ring that bell to get notified of all new videos. Thanks so much for giving me your time and watching.